Welcome back. So, this was the last slide which we were discussing about the different type of terraces, and this is another example from Himalaya, as I told that we have this in the foreground. We are having the Indo-Gangetic plain, and this is your Shivaliks, and you can easily demarcate it because if you look at the tonal variation as well as the some features which are indicative of drainage or the smaller streams which are seen here. Okay, so this portion is comparatively elevated than this one, and if you take the profile like this, okay, then you are having something like that. Okay, so you have an elevated portion here. The major channel you can easily identify, which goes here, and then again you are having a very wide valley, which is indicative of again the braided river system here. So, you have what you have here is you have meander, you have straight channel, and then you are coming to the unconfined area from the confined one. And this portion, this is the white portion which I will trace here. This one is the top portion, and this blackish portion is your escarpment here. That is the, and then you are also having the incised valley. And the photograph which has been shown on the top was taken from this location looking this side. Okay, so what you see in the field photograph, so you are having the incised channel, and on the top you are having very young channel fill deposits. Okay, again this landform can be classified as an strat terrace in the region, and why it has formed is because of the uplift which is going on along this line. Okay, so this is the area is getting elevated as compared to the Indo-Gangetic plain. Now, in coming few slides, we will try to understand that how we can identify the landforms using the or subsurface structures or lithology using the drainage pattern. Before going to that, let us just look at that what is the we exactly mean by the depositional terrace. So, the previous photograph and the which from the field is of strut terrace, but this is a depositional terrace, and as I told that the depositional terrace is that terrace which will formed by the incision within the valley fill material. Okay, and also we term this as an channel fill or valley fill terraces. Okay, so this is the channel boundary, and you have which has incised the bedrock, but then it got filled up and again incised. So, this is the terrace step, and this is the escarpment here, and this is the your valley floor. So, this terrace is formed where the river has cut its own deposit, hence we term this as an channel fill deposit or fill terrace. Okay, so this has been termed as fill terrace, or you can say depositional terrace. Okay, now if it cuts through here, that is in bedrock, then you will say this as an strut terrace. Okay, now if you consider the complete journey of a river channel from its origin to its mouth, then you will come across different landforms. Okay, so we have, as we have been talking about, erosional landforms and depositional landforms. So if a river is considered in the youth state, okay, then what type of erosional landforms you will come across? Because when you are preparing a detailed geomorphic map or a landform map using satellite data, and you are interpreting the satellite data, you will also have to classify the landforms. Okay. And you will also have to demarcate, putting in standard symbols that this feature is indicative of a particular landform. Okay. So, based on that, you have different stages. You have youth stage, you have mature stage, and you have old stage. And what are the related landforms here? So, in the erosional landforms, we will see in the youth narrow V-shaped valleys, gorges, valley length increases due to headward erosion, and this headward erosion will keep on adding more area to your drainage basin. Okay. And development of the waterfall. This is like a very youth stage where you will find this type of features. Okay. In the depositional landforms, for the youth stage only, you will not see much of deposition, no floodplains or meanders will be seen. In terms of the comparatively, you will see less meanders, deposition of alluvial fans in the foothill zones, alluvial cones, and so on. Okay. In terms of the mature, you will have well integrated system, no waterfalls, because you have exposed the landform for a longer period compared to the youth one. Okay. So, it will keep on eroding, and you will not be able to see the features which you are going to encounter here. Okay. Then you will have, of course, meanders. Then because of the channel migrations, you may come across the cutoff channels. Okay. You may come across a broad symmetrical or asymmetrical valleys. Okay. Number of tributaries reduces. Okay. Then in terms of the deposition, you will have floodplains, natural levees, formation of terraces, meander scars, point bars, back marsh, okay, or back swamp we say, and deposition which will be deposited in a form of your oxbow lakes. And oxbow lakes are nothing but you are having what you see the cutoff channels. Okay, mainly. Then in old stage, what you will see basically is very few tributaries, extremely broad valleys, okay, and deltaic plain. So, mostly if you start this, what you will find that if you are having the origin and finally you are getting this channel meeting the ocean. Okay. So, you will have a very youth stage here, you will have comparatively mature here and an old also, of course, and then what you see is that this will be in the older one. Okay. And in terms of the valleys and all that, what you see is that, like, if you have to mark the V-shaped valleys, then you will be able to see clearly this type of, if you are viewing the satellite data in 3 dimensions, you will be able to make out, and the broader channels will be something like this. Okay. So, you have a U-shaped valley and a V-shaped valley. So, this type of features also you will be able to mark using satellite data, and then you can classify your area accordingly. Few more things and terminologies which you will be, this will be helpful in categorizing the landforms. For example, you have the consequent stream and the subsequent streams, but for this again some help will be required in terms of the field investigations. Okay. So, usually the consequent streams are been classified as a stream that flows on the slope. Development of slope may be because of sudden uplift. Okay. So, you have a gentle slope here, and the streams which will develop over the slope are termed as consequent streams. Okay. Whereas the subsequent streams are those developed later on. Okay. So, for example, you have an folded terrain here, and then you have the streams which are been developed on that. Okay. so which are developed later on, carving the softer rocks and flow at almost right angle to the original slope, okay, whereas the consequent streams are flowing along the slope, that is from the higher to lower, whereas this one, this will be developed almost right angle to the original slope. Original slope is what is the original slope we are talking here is this one. This area is like this, okay. So if I extrapolate this one, this will be something like that, okay. So the original slope is here, this is the original slope, but the stream has cut through the softer rock and flowed almost right angle to the original slope, okay. So this type of streams which are developed in the folded terrains are termed as your subsequent streams, okay. Then we have antecedent streams, and this has been observed close to the mountain fronts, and the best example to see the antecedent stream is close to Himalayas, where the uplift is going on, which is resulting into the stream incision, okay. So one of the photograph which I was showing, where we were talking about the strat terraces, if you refer that photograph, you will be able to demarcate easily that close to the hill front or the mountain front, you are having a deep incised valleys, okay. So these streams have cut through this uplift here. So these are termed as antecedent streams, okay. Then few streams are been termed as superposed, okay. So what are those? They will develop over the underlying rock with different lithologies, and they will flow across that actually, okay. So these are the superposed streams, okay. And further, one more thing which has been shown here is the unconformity, okay. So you are having the inclined beds here, and then you are having the horizontal material, horizontal layers which deposited later on, could be related to the same stream, okay, but they are the later on deposits, okay. So this has been also termed as the unconformity, or we can also say an angular unconformity here. So these are the examples of the superposed streams, okay. Now one more feature or the signatures we often come across in the hilly terrain, and as we were talking about that headward erosion plays an important role in the extension or the development of any drainage basin. So stream piracy is nothing but the term which has been given for stream capture. So what happens is, in this process, that due to the rapid headward erosion, a stream may breach the divide, okay. So in one of the lecture we were talking about that if suppose we are having stream here, then we are having smaller tributaries joining here, and then another stream here, and we are having smaller tributaries joining here, okay. So this is the boundary or the drainage divide of one of the basin here, and then this boundary is the another basin, okay. So maybe what will happen, because headward erosion means it will keep on eroding this side, okay, this will keep on eroding this side. Time will come, this divide has been breached, okay, and one of the channel will start flowing in different basin, okay. So this is what is we are talking about the stream capture. So stream capture is the interception and diversion of one stream by another stream, okay, that is extending its basin by erosion in the headward directions, okay. So this is your headward direction, and this divide will be breached, and one stream will capture the another one, okay. So diversion of flow will take place, where the diversion of flow into new channel may leave a wind gap because the older channel will dry up. So, if you see this example here, what it shows is that you are having, for example, this area is uplifted. So, you are having the drainage divide over here. So, this stream is flowing in this direction, another stream is flowing in this direction. Because of the headward erosion, which is moving in this direction here, and the erosion is taking place like that, okay, the time will come that some areas will be breached off, okay, and this is what we say breach of the divide, okay, and the whole drainage, for example, is now taken up by this one, okay. So, some of the streams here may be dried up, and that what we call the paleo channels, okay, and it will be either in form of a wind gap or paleo water gap. Okay. Now, this is another important part which you will be using for interpreting the subsurface lithology, either we can say, or the structures based on the drainage pattern. Now, the drainage pattern is the geometry of stream network in a region that reflects aspect of underlying geology. So, what is the different lithology of the area, you will be able to make out easily based on the drainage pattern. Okay. So, drainage pattern, for example, these are few which are very prominently seen and commonly seen. One is dendritic pattern, develops above homogeneous geology. Either you are having very horizontal or gently dipping strata. Then you will have trellis pattern, develops over tilted or folded strata. Then you are having radial pattern, which develops over the domal or volcanoes. Okay. So, if you are having domes or volcanic areas, you will be able to see the radial pattern. We will see few of the examples of this, okay. But before that, let us look at the pattern in detail. Okay. So, dendritic pattern, it is irregular branching pattern, tree like in many directions. It is commonly seen in a massive rocks and in flat lying stratus or on the flat lying stratus. Due to strong resistance of crystalline rocks, headward erosion development of the valley is negligible. Or you are having either the homogeneous material and gentle slope, you will be able to see the dendritic pattern. Coming to the parallel, it will develop over the sloping surface, very much similar to what we were talking about the consequent stream. Then common in terrain with homogeneous rocks, but mostly what we are looking at, it will develop along the slope. Development of parallel rills, gullies or narrow channels are commonly seen on gentle sloping surfaces. Coming to another one, radial. So, this portion, the center portion is elevated here, this is the higher place. So, stream radiates out from the center of the topographic high, common in volcanic terrains. Then you have rectangular patterns. Usually such type of patterns are marked by right angle bends. Okay. So, you have very typical right angle bands. Commonly seen due to presence of joints and fractures in massive rocks or foliation or the foliated metamorphic rocks. Okay. So, you will be able to see similar pattern, okay, which we call as an rectangular pattern. So, we will do one or the two exercise on this, which will help you in understanding the subsurface lithology based on the drainage pattern, as well as you will be able to identify the landforms which are associated with such drainages that is, the drainage basically reflects what exists beneath. Okay. Then we have trellis pattern. Again, rectangular channels or channel arrangement where the main stream are parallel and very long. Okay. This pattern is common in the area where you are having the edges of folded sedimentary rocks, and this folded sedimentary rocks will have weak or resistance rocks. So, this type of trellis drainage are mostly seen in that regions. Okay. So, what will happen, the folded sedimentary rocks which are with weak and resistant rock layers, and the edges of the folded one, this will form a very long and parallel belts. Okay. Then you have annular drainage pattern. Stream flows almost circular or in a concentric path along the belt of weak rocks in an area which are marked by domes or basin. So, let us see few example of further of the dendritic pattern, how it looks like. Okay. So, you have very small multiple stream and it gives a tree like pattern. Radial, you are having an elevated portion here. So, either this is a dome or a volcano, then you will have a radial pattern which are radiating away from the center, which is the higher point. You have a rectangular pattern because of the fractured rocks. So, you have almost in right angle pattern you will see, whereas the trellis one, this is what you see here, is that the main channel is very long, flowing across the folded regions, and this will be also parallel to the folded region. These are the tributaries. So, you are having resistance rocks here, and then you are having the soft one. Okay. Now, if you look at the Himalayan terrain, this is a foothill zone, and this portion what you are looking at is your anticline. Okay. So, you have multiple folded belts here, okay, as you move towards the higher Himalayas. So, one of the example, if you look at, this is the 3D perspective view of the same area, looking from here towards this side, and what we see in terms of the elevation change here, that you are having a very sharp demarcation over here. Okay. You have an Indo-Gangetic plain, and this data which we used was SRTM data, satellite radar topographic mission data, and Landsat data, and we generated this perspective view, okay, 3D perspective view. So, what we found was that of course there is the elevation changes here, and this portion is a very flat area which is sitting in the on the top of the anticline, and then we are having in basin, or we can say this is an intermountain valley between the two mountains. And further, if you move ahead, this area what we have marked is a warped area, and this we interpreted based on the drainage. So, let us go back and look at what exactly, if you look at this drainage, there is small stream, these are all deeper part here are indicative of smaller streams. Okay. So, what we found is the streams are flowing like that, these are going in this direction. This is what we have marked as a warped area. Okay. So, this is something like domal area which we were able to pick up from here. Now, coming to this, probably I am having the next slide. This is what you can mark, okay, easily. So, you are having the darker portion here. This is again in corona satellite photo, the lighter ones, and you can see some settlement indications. This is Chandigarh area. So, this is a boundary between the Indo-Gangetic plain and Upper Shivalik, And what drainage pattern you will be able to pick up, as we have seen in the previous slide, is typical of a drainage which is indicative of dendritic. So very closely spaced, and then we are having a very tree-like system. These are white portions which have been seen here, or the stream. These are the major streams which are flowing. But in terms of the tributary and whole drainage basin, if you mark for even for the individual one, you will be able to mark this as an dendritic pattern. And then we have alluvial here as a basin area. Again, we are not having the dense drainage as we see here in this portion, the blackish one. This is in whitish. Again, this is in flat region, and then there is a boundary here further going up. We have a different drainage pattern here. Further, if you look at here, what we can be able to pick up, you have meanders here, whereas here you are having almost straight channels, and this you can classify these channels as all parallel channels, okay, or parallel drainage, which have developed over the slope. Further, when you extract the drainage from the satellite topographic, that is SRTM data, satellite radar topographic mission data, having understanding that what type of drainage pattern we can classify, this pattern can be again classified as an same as a dendritic pattern. Okay. So you have darker blue is your major channel, which is flowing along. So some places you will say that, okay, fine, this is a trellis pattern, then it's crossing this ridge line. So this is your antecedent drainage. Again, similar to that, you are crossing the ridge line here, that is a folded belt. This is an antecedent drainage. These streams are flowing on this direction in this one, because we are having the smaller stream joining the bigger one, or the higher order streams, and here we are having these streams which are joining the trunk stream here. So if you draw the line here, and you will be able to clearly demarcate the boundary. Now what is this? This is your drainage divide. Okay. And for this, you may be able to mark the basin area. For example, for this, let us mark this one here. So it may come here, and this one is of course over here. Okay. So these are the basin areas you are having. So drainage basin, and you are having the drainage divide here. Okay. And the drainage pattern which you are looking here is typical of dendritic pattern. Now we, based on when we were doing some of our studies here in this region, we come across very interesting thing, and that we were very much inclined to go and feel and check what we have been able to identify from the satellite data is correct or not. Okay. So this is again a Landsat data of from northwest Himalaya, and these are the clear-cut boundaries which you can see. This is false coral composite. So you are having this darker green colors are thickly vegetated areas, and this is in Chandigarh anticline, and then further you are having a valley here which is termed as Pinjore Doon, similar like what we are having Dehradun, and then we are having the lower Shivalik hills. Okay. So when we were looking at this region, what we found in particularly this. Okay. Now this is what is the geomorphic map we are having. Okay. So as we were talking that you can classify the terraces and other landforms as T0, T1, T2. So here we have marked as QT0, QT1, QT2, QT3 and QT4. Now this is just few streams which we have picked up here. Okay. So these are the major streams, and we are having the smaller tributaries. What we can do is we can come over in the next lecture and we can talk in detail about this. Okay. I'll stop here. Thank you very much.